Okay, so I know in the last video I said I'm going to go through both. I think I will. I might separate that example 4 into another video just because I want to talk more, more maybe properties. But I definitely want to start at number 5, sketching these. Because this also talks about translating things left and right and also looking at other bases. Now I can see, right, base 10, common log, base 3, so how does that impact the graph? And really, its image will still be the same, it's just going to impact what are the values of x, what are the values of y. This graph, natural log, so it's base e. This x minus 1, again, because it's factored within the function, this is a left-right translation. And remember, I can't take the log of 0. So whenever this thing's equal to 0, that's going to determine where my vertical asymptote is. So 1 would be the vertical asymptote, which again corresponds to shifting things to the right 1 unit. So that's exactly where I would start. I'd start at x equals 1 as my vertical asymptote. And then I just go ahead and draw the, close to the asymptote, and then takes a sharp right turn. That means we used to have 1, 0 as our intercept. Now we have 2, 0 as the intercept. And then all of our values like e and e squared, would be pushed to the right one as well. So then it gets, again, really, really awkward in terms of labeling, because this point would be e squared plus 1, sorry, not e squared, which is normal e plus 1, and then 1. And again, the whole idea of this e plus 1, when you take that and subtract 1, you just get e, and then natural log of e is just the 1. And then if you wanted to plot like another point, you would say e squared plus 1, and then that y value would be 2. Because again, e squared plus 1, take away the 1 in the function, and then natural log of e squared, which is 2. Okay, now log base 3. Remember, log base 3 counts powers of 3. So when I try to find quote-unquote nice points, think about what are powers of 3 that I'd be able to evaluate. The other thing is this x plus 3, because again, it's factored, it's a shift to the left 3 units. So my vertical asymptote now will be at -3. So 1, 2, 3, there that is. X equals -3. And the intercept that used to be at 1 is also shifted to the left 3. So now I'm at -2, 0. Hug the asymptote, take that sharp right turn. So this point right there is -2, 0. Now, in order to find like nice points, again, you might want to think about making powers of 3. For example, if I choose x to be 0, which is just coincidentally the y-intercept, it does not always going to work this way, but if I choose y to be 0, 0 plus 3 is 3, and so basically log base 3 of 3, log base 3 of 3 is asking like, well, what power of 3 is 3? It's the first power, so it's 1. Remember, these are counting exponents. I'd like to maybe make this a 9. So if I choose 6, because 6 plus 3 is 9, then I have, log base 3 of 9. What power of 3 is 9? It's the second power. So if I put a 6 in, 6 plus 3 is 9, log base 3 of 9 is 2. The next one, I know I only said 2 points, but just so we kind of follow along, the next one I'd want to try to create is a 27. So think about what x would give you 27. It would be 24. And that's think about that, the 24, I have to go way over here. I'm not even on the screen, right? Like literally, I'm not on the screen. And that would get up to 3. So that's why it takes logs so long and so slowly to rise, because you have to go out so far to get to the next power of that value, okay? All right, next. So I see log, and I do not see a base. So that tells me it's common log, powers of 10. This negative is a reflection over the y-axis, because all of the x's are switching values. And then, let's see what we read. A translation up 4 doesn't affect the vertical asymptote, but it will affect our values. It will affect where our x-intercept was at. So this is normally where it goes. Now I'm reflecting it over this way, but this point is actually going to be shifted up. 1, 2, 3, 4. This point will actually be right there. So that's the old y-intercept, or sorry, x-intercept. Hugging the asymptote, taking a sharp left turn. Okay. So then this point right here, x equals 0, first of all. This point right here would be -1, and then 4, because everything got shifted up 4 units. Okay. Now, here, kind of like the last one, since the base is 10, we want to try to find powers of 10. So the very first power of 10 could be 10 itself. But what would I substitute in here to get a 10? It's actually going to be -10, because negative 10 becomes 10. And so if you think about, okay, what's log of 10? In other words, what power of 10 is 10? It's the first power. So that becomes a 1. But then don't forget to add 4, 1 plus 4, so our y value would be 5. Okay? The next power of 10 is actually 100. Right? So how do I make this thing a 100? Choose -100, which is like way over here. So, I mean, again, maybe I won't draw this to scale, clearly. But this point right here, we could think about that as -100. And then, because -100 becomes +100 and the log of 100 is equal to 2, don't forget to add 4, then we get to 6. So again, think about like 4, 5, 6. Those y values are increasing one at a time based on the power of 10. And look how far out we have to go. 1, which is 10 to the 0. 10, which is 10 to the first power. 100, which is 10 to the second power. I mean, 1,000 we have to go all the way to 1,000 to go from 6 just up to 7. So again, they take a while to increase. And that kind of goes back to the question here where it says, what effect does the base of a logarithm have on its graph? Okay? The larger the base, that means it's the larger powers. It's going to take a lot longer, so on the x-axis, or positive or negative, to continue to increase. Okay. Let's see. I think I might want to go to maybe example E next, because I want to remind us that we should probably be factoring things out. Right? This is really log base 4 of the opposite of x minus 5. Right? You could take out a negative, and now it's x minus 5. And so now I see this negative. Okay, all of the x's have switched, so it's a translation over the y-axis. Take that image, shift it to the right 5 units. So either case, I can still see 5 is the vertical asymptote, because 5 is what is going to make that equal to a 0, and I can't take the log of 0. So here's my vertical asymptote at x equals 5. And again, normally the log shape is this. I'm going to go up and to the left because of that reflection. And label this point is 4, 0. Okay? Now, we're base 4, so we want to find powers of 4. So I know that log base 4 of 4 would be 1. And log base 4 of 16 would be 2, because 16 represents the second power of 4. So your job then is to take the set of parentheses and try to create those values, like try to create a 4. And you can look at it from either part of the function. So here, if I this might be easier, let x be 1, because 5 minus 1 would give us 4. And what's the log base 4? 1. So I want to choose x is equal to 1. So at x equals 1, maybe blue, I guess. X equals 1. So again, log base 4 of 4 is 1. Okay. And the next power of 4 is 16. So I need to choose something that would give me a 16. Well, 5 minus -11, which is way out here. If I choose -11, that will give me a 16, and then log base 4 of 16, which is equal to 2. And I probably should say this, although it should come, hopefully it makes sense, that these values are not linear, right? They're not linear to get from 4, 0 to 0, to 1, 1, that looks terrible, 1, 1, to get to negative 11, 2. I mean, they can't be linear because these aren't linear functions, right? These are logarithmic functions. So there's no order in terms of linear fashion here because they're not linear functions. Okay, I think I might want to do G next in this video. I know we've got about like 10. We've already been taping for 10 minutes here. Let's look at this one. I don't have to do any factoring because it's already factored, but I do have a couple translations. This one, first of all, over the y-axis. This one shifting left 8 units, and this one then shifting down 2. So the biggest thing here is thinking about that vertical asymptote. When is that equal to 0? That equals to 0 at negative 8. So I would, I don't know why I did that. Let's go green. So at negative 8, I know there's going to be a vertical asymptote. And again, putting negative 8 in there causes that to take a log of 0, which you cannot do. It's undefined. Okay? Now, normally my log graph would look like this, but this reflection here is over the y-axis, so now my log graph would look something like this. The one difference is that this whole image needs to be shifted down 2 units. So this value right there, where it crossed, will now shift down 2 units. So 1, 2, and maybe right there. So that's what I'm aiming for. So I'm close to the asymptote, and then turn left. And what is that point? Well, it's negative 7, right, because you're always 1 away, and then down 2. So that's that point right there. Okay? And again, how did I get this negative 7? Well, think about normally the x-intercept is at 1. We're shifting everything to the left 8 units. 1 minus 8 is negative 7. Okay? And now we need to count powers of 10, because common log is base 10. So maybe I'm looking for log of 10 and log of 100. When would this thing equal 10? Well, at x equals 2, right? 2 plus 8 is 10, and the log of 10 would equal 1. So then I get a 1, but make sure you make it a negative 1, and then subtract 2, so that's negative 3. So when x is 2, the output would be negative 3. And again, we chose 2. 2 plus 8 is 10. Log of 10 is 1. Make it negative and subtract 2. Okay? Now, we need to get to 100. So clearly I'm not going to draw this to scale. But what value of x gets you to 100? 92. So 92 plus 8 is 100. The log, common log, base 10, of 100 is 2. So then I have negative 2, take 2 more away, which is negative 4. And again, our y values are decreasing by 1 because I've just increased the power of 10. If I wanted to get to the next one, like 1 lower, so negative 3, negative 4, negative 5, I'd have to go to the next power of 10, which is 1,000. So log of 1,000, which equals 3, which means what value would create 1,000? 992, and then I'd be able to get to that last value. Okay? So I like these notes. I think that's good. And like I said, maybe I'll do one more video to kind of complete example D, F, and H, or at least show you the solutions to those. But that is what you should know and kind of expect. In class tomorrow, you'll have an opportunity to practice. And feel free to go back and reference this if you have any questions.